Emotions is immiscible.
Mm-hmm.
The solution is no surfactant. Suspension, no surfactant. Emotions, surfactant. Solutions,
Surfactant. Also, Google it, Vincent. Google that word. So
surfactant.
surfactant. Mm-hmm.
Solutions, small particles. Suspensions, large particles.
Mm-hmm.
Emotions, large particles.
Mm-hmm.
Solutions, usually clear. Suspensions, usually cloudy. Emotions, usually a solid color.
Mm-hmm.
Solution, stable mixture. Suspensions, unstable mixture. Emotions, limited stability.
So would a suspension of oil, would oil and water be a solution or a suspension?
I want to say it's suspension.
Because it's an unstable mixture.
Yeah.
Oil is going to rise.
Yeah, the oil is
Well,
going to
depending on
separate
how big.
or rise. Because we was talking about peanut butter. That oil rise if it sit a long time. The oil is settled on the top. Mm-hmm.
Solution is witch hazel.
Mm-hmm.
Suspension, calamine lotions. Emotions, shampoos and conditioners.
Limited stability. That mean, what do limited stability mean? That mean for a certain amount of time, it'll be together. Then it'll come apart. It's also good to use certain products within a year's time, within 12-month frame of time, because its potency, its effectiveness is not good.
Yeah.
Also, that's why going to shop in certain places and certain hair stores that don't get a lot of turnaround traffic, and people be like, "Oh, I bought this from that place," whether it's Walmart or whatever kind of store. If they don't sell a lot of that, you get an old bad product, which would heighten the risk of your hair breaking off. You know how so many people don't talk about they don't had a bad relaxer, brought it from an old store that don't even barely sell relaxers or whatever like that. No, you don't. Yes, you buying something from the grocery store. People here getting groceries, not a relaxer. That's only an emergency. And don't get a chemical, more so, or colors. Get a shampoo, worst case scenario, if needed, or hair oil or something, if needed. Not something that can alter your hair, because it done been sitting. It is a chemical, and what do chemicals do when they sit? Either they're not as potent, which means you would leave it on your hair longer thinking that it's going to work better. And no, now you got a chemical burn. You still don't have your hair properly relaxed, texturized, or whatever you was trying to do. Yeah, because you bought outdated bad products and they left it on the shelf. They didn't throw it away or whatever they needed to do as a business. Yeah. All right. So, time with proper formulation and storage in emotion may remain stable for at least 3 years. At least 3 years. It could remain for 3 years. That's funny that we're reading that, because I know for a fact those products that's on that back bar are over a year. I purchased those over a year ago. Those are shampoos, those are conditioners. I knew they were still good. I knew the company that I purchased them for was good. And I know that before the year is out, we're going to be done ran through them, because I know that we need new products. You know what I'm saying? So that is our responsibility as barbers, to be kind of in the know. That's why I don't shop anywhere. I don't do anything with anybody, because I want the quality, and I want to make sure that they understand the knowledge. They're educated about the quality. So of course nobody gonna spend or do cheap investments in the quality and the time. The shelf life won't last. So now you're losing money. Ultimately, you're losing money if you don't understand the shelf life of your stuff. So I'm like, okay, 3 years, yeah, we working. That's why our dispensary was able to be full based off the stuff that I already technically had. Yeah. 4 times such as this. But I already know as we rolling through it, boom, we rocking, we rolling. That's why some things, hey, use it on the mannequin. This real people, because you got to know your stuff. If not, it could bite you, because then you will have reactions or outbreaks or different things happening, and then that will be on your liability. You will be liable for that thing. So as a professional barber, a business owner, you want to keep these things in mind. It don't matter if you got to run sales, special, whatever you need to do, you need to move these products, because after a certain amount of time, it's going to be money down. Money down. Yeah, that's not on your profit side. That's on your loss. All right. So, pick up at that bullet.
Mayonnaise is an oil and water emulsion
Mm-hmm.
of two immersible liquids. The egg yolk in mayonnaise emulsifies the oil droplets and disperses them uniformly.
No, it's uniformly.
Uniformly in the water. Mayonnaise should not separate upon standing. A review table 7-3 for a summary of the differences between solutions, suspensions, and emulsions.
So the egg yolk, that's what we was discussing in class. Just that is what helps the even distribution of the oil. If that egg yolk did not play a part in the ingredients for the mayonnaise, then that it would have not been able to stay together or have that limited stability. If you remove the egg yolk, that oil and water gonna do what oil and water naturally does: separate. It do not stay together. It don't mix. But once you put that egg into the equation, now you have something to help stabilize the oil with the water, which the oil is the solute. They're what they said is immiscible. Mm-hmm. So now you got two immiscibles together, and it's gonna be a limited, because it's limited stability versus it would have been an unstable mixture. Oil and water, they don't mix. All right.
Shampoos and conditioners are examples of emulsions
Mm-hmm.
used in barbering services.
Mm-hmm.
Cosmetic emulsions should be used within 1 year of purchase.
All right. So these are timers. You see, they put in times, years. You got 3 years. Cosmetic. What it said up here? 3 years for the storing of emulsions may remain. That means all of them do not last 3 years. But within that year, you should be trying to use your cosmetic, your stuff within a year. Mm-hmm. All right, surfactants.
Surfactants for base detergent is a substance that allows oil and water to mix or emulsify by reducing surface tension. The term surfactant surfactant is a concentration for surface active.
Contraction. That's contraction instead of concentration. I know that word is
contraction for surface active agent.
Mm-hmm. So you see how I was saying that the surfactant, the base detergent, is a substance that allows the oil and water to mix or emulsify by reducing the surface tension. So that means that's what's happening. They got tension. Tension means resistance of naturally not coming together. Okay, so I just wanted to just throw that in there so we can understand what's going on with that suspension.
And surfactant's molecule has two distinct parts. The head of the molecule is hydrophilic,
Mm-hmm.
water loving,
Mm-hmm.
and the tail is lipophilic, oil loving.
So figure 7-10, where it's talking about oil loving tail and water loving head. Got a little illustration right there to kind of give an example of what that's talking about with the hydrolyphic and the what to say how you want to say lipolyphic. Okay.
Since life dissolves light, the hydrophilic head dissolves in water, and the lipophilic tail dissolves in oil.
Mm-hmm.
This configuration allows the surfactant molecule to mix and dissolve in both water and oil to join together to form an emulsion.
Mm-hmm.
In an oil and water emulsions, droplets of oil are dispersed in water, where they are surrounded by surfactants. The lipophilic surfactant tails point inward with the hydrolytic tail pointing outward,
Mm-hmm.
which keeps the oil dispersed in the water. Most of the emulsions used in the barbershop are OW emulsions
Mm-hmm.
and do not feel as greasy as water and oil preparation.
And you see how it says OW, oil in the water. So the water is the what?
It's the water loving head.
No, what is the water?
Oh, that's the
Solvent.
The solvent. I just want to make sure. I'm jog your memory. That way y'all getting it down pat. All right, do that last bullet, my son.
In a water and oil emulsions, droplets of water are dispersed in oil, where they are surrounded by surfactants. The surfactant tails point outward and the head point inward, which keeps the water dispersed in the oil. Cold cream is an example of a water and oil emulsion.
Mm-hmm. So cold cream.
Okay.
What is an example of a cold cream?
It's kind of like a treatment.
Okay.
Cholesterol.
Okay.
That's what I'm thinking about.
Okay. I'm just asking. Look up what is an example of cold cream. Mm-hmm. So did you know 70% of the Earth's surface is covered in water? The human body is 65% water. I thought the human body was 70% water.
okay.
Did they change it?
It varies. I think it varies per book and their understanding.
Oh, okay. Because I
I've seen
sure
it
thought we
higher.
was
I've
70.
seen it, yeah, I've seen it higher.
Yeah, I'm like, I thought we was 70 because it would make sense for us and the Earth to technically have the same number if you want to think, theoretically. Because I've always, this is my first time hearing 65.
Discuss the properties of water and pH.
So I'm gonna read this one.
Okay.
Discuss the properties of water and pH. After reading this section, you will be able to define pH and describe the pH scale. So what does pH mean?
Is it physical health?
Is it the what?
Good morning.
Yes, ma'am. Is it the what?
The
Help them out, one second. What does pH mean?
Personal health?
Appreciate it. You're welcome. They said they ain't have no book.
Okay.
All right. Okay, I see all of it.
As long as they got syrup.
Yeah, they got some of them.
Mm-hmm. All right, make sure y'all pull out y'all pH scale. That's in y'all handbook too. All right, explain how product pH levels affect the hair and skin. All right, so water, as you can see on the board, where I have it right here, H2O. So what does the H2O is? What does H mean? Do y'all know y'all atoms?
Hydrogen.
Y'all know? Yeah, hydrogen. How many hydrogen are there when you're dealing with water?
It's 2.
Yep, 2. And then with oxygen, how many is it?
1.
Yep, 1. All right. It's basic chemistry. We ain't gonna get overwhelmed. All right. So the most abundant and important of all chemicals and compounding, I mean, and composing about 71% of the Earth's surface and an average of about 65% of the human body. Water is known as a universal what? Solvent. A universal solvent. Because it dissolves more substance than any other liquid. That's why. That's what makes it universal, because it dissolves the most. No other liquid can do what water does. And to think rivers of living water can flow from your belly. Come on here now. My God. All right. Distilled or demineralized water is used as a non-conductor of electricity. While water contains certain amount of mineral substances, is an excellent conductor of electricity. So distilled water is a non-conductor of electricity. Please locate some distilled water in the classroom. Go grab it and let's see what it's talking about. So what is that distilled water talking about?
It says distilled water, source, deep well, Oakland, Florida.
Okay.
And
Did the video not show up? I'm talking on TV.
Okay, it says Barber by Silver Spring Bottle Water Company, processed by steam distillation, micron filtration,
Mm-hmm.
ultraviolet light, and oxidation for natural information.
Let my son read it. What it's saying?
Processed by steam distillation.
Oh, okay. Did the playback play back right though?
Ultraviolet light, oxidation for nutritional information called over number.
Okay. What y'all discovering anything from reading about distilled water, demineralized water that is used as a non-conductor of electricity? Because regular water has minerals that helps conduct electricity. So if you think about back in the day, what contraption helped electricity move through the currents of water? It's like a throwback right here. I'm calling it a contraption. It's a
Windmill.
Yes, come on. You better. Okay now. You know, we got our love.
I was thinking about, back in the day when they did their moonshine.
Yeah, and I'm like, the windmill was in the water, and it had a job to do, and it was conducting, it was moving, keeping power to the city or whatever it was doing. Cause we got the water towers right there. We got one on Cushman. But I'm like, that windmill, that was a good one right there. Okay. I didn't want to say, I'm like, what can I say? Contraption. 2023 is a contraption. Okay. So water is purified through boiling, filtration, and distillation. Didn't you see something about filtration on there?
and ultraviolet light.
Mm-hmm. Yep. So that's the purification of that water because again, it has minerals in it. Just like sometimes they do a boiling advisory when certain things be going on.
Yes,
We don't technically know everything what's going on, but hey, that's an emergency news flash. Oh, glory to God. All right. So boiling water. All right, pick up with them bullets right there, Vincent.
Boiling water at 212 degrees Fahrenheit destroys most microbes and renders it suitable for drinking.
Mm-hmm.
During filtration, water passes through a porous substance such as filter paper or charcoal to remove organic materials. Correction. Distillation is the process whereby water is heated to a vapor in a closed vessel. The vapors are captured and passed through a tube into another vessel where they are cooled and condensed to a liquid. This type of purified water is used in the manufacturing of cosmetics. Salt.
Interesting, right?
Yes, didn't know that. Salt water is rainwater or chemically treated water that
Stop right
has.
there for a minute. I just got a visual.
Mm-hmm.
So with the process of the vapors,
Mm-hmm.
how they make the makeup, now it makes sense when you adding water itself, it changes it again. Like some of the cream, it diluted a little further.
Or when we
When
applying
it's
it,
fried, it loses its.
it helps spread it or help move it
Yeah.
too. Mm-hmm.
Okay.
Yep.
Okay.
Because again, the water is a universal solvent. So it's used to create and make, it's used to remove, it's used to help spread it.
Everything.
Mm-hmm.
Salt water is rainwater or chemically treated water that has low levels of mineral substance such as calcium or magnesium salts. This type of water not only allows soap and shampoos to lather freely, but can also leave the hair and skin feeling too sleek even after thoroughly rinsing.
Mm-hmm.
Conversely, hard water contains mineral substance such as calcium and magnesium salts that can interfere with the lathering and foaming process. Hard water may be softened by distillation, water softening units, or by adding sodium carbonate. Washing soda, however, today's hair products and modern filtration systems have helped eliminate some of the problems associated with hard water in the past. If you are in doubt about the quality of the water in the barbershop, use a test kit designed to measure both the water hardness and pH level.
So you ever heard when people be talking about they washing with hard water? Is that in Georgia? Where people be saying they water hard at? Certain cities and states.
Like
And they
most like the inner city.
mm-hmm. And they like, oh my goodness, my skin done changed since I moved here and this and that. I don't even wash my hair here because of the water.
Yes.
So just being able to identify that. But it's through touching, touching, feeling, seeing the difference, what's drying your hair and everything out. All that play a part in it. Mm-hmm.
Learn about water and pH potential hydration.
What was the question I asked you?
What was pH?
Define pH and describe the pH scale. So what does pH mean?
Potential hydration.
Hydrogen.
Hydrogen. A basic understanding of ions is important to an understanding of pH.
Mm-hmm.
An ion is an atom or molecule that carries the electrical charge. Ionization is the separation of a substance into ions.
Mm-hmm.
ions, yeah, there you go, ions that have opposite electrical charges. A negatively charged ion is called an enema. Hold on, I'm saying it right.
Google it.
Okay,
It look like an onion.
And
Onion.
and iron.
an ion.
Yeah, Google it to see what how it's pronounced and what it means. So while he's looking that up, did you know you can test water to determine whether or not it's soft by using a soap solution? Use the following steps to test the water softness in your area. Dissolve 3/4 of an ounce of pure powdered Castile soap in a pint of distilled water. Use the second pint of water to fill halfway with tap water. Add about 7 drops of soap. Shake the bottle vigorously. If lather forms at once and persists, the water is very soft. If the lather does not appear at once, add another 7 drops or ounces of soap solution. Shake it again and add. If an additional 7 drops or ounces of soap solution is needed to produce a good lather, the water is hard and should be softened for hair services in the barbershop. So put a star on that because we're going to test our water.
My water is harder in my salon compared to here.
Oh, you tested?
I'm just reading what this is compared to doing lathering.
Oh, you can already tell. Uh-huh.
But then again, it could be personal, just dirty.
Well, before you add any product, make sure you do thoroughly rinse before adding.
Yeah.
Cause removing that stuff so that hair can be ready to receive that solute is important. Cause soon as that solute hit that water, it should just go ahead and start honestly lathering. Because the solution is the shampoo, the emulsion. Yeah. How do you pronounce it? Anion. Anion.
A negatively charged ion, one that would be attracted to the anoid in electrolytes.
Oh, that's the definition. Okay, finish reading.
The ionization of the water is what makes pH possible, because only.
Where you at?
Right.
I thought we was on a negatively charged ion is called an anion and a positive.
Where?
On page 86, 88.
Oh.
Where you done went?
Oh. I was down. A negative.
And we still was at the top of the page.
A negatively charged ion is called an anion, and a positively charged ion is called a cation.
Cation. It ain't a U in it. Cation. Yeah. Okay.
Cation. In pure water, some of the water molecules ionize naturally into hydrogen ions and hydroxide ions. The pH scale measures those ions. The hydrogen ion is acidic, and the hydroxide ion is alkaline.
So, like on the pH scale, it's a acidic and an alkaline. Then you got neutral. So, where is our hair and skin on the scale?
7 neutral.
Where?
Okay.
It ranges from a 4.5 to a 5.5, averaging of a 5 on the pH scale. Our hair and skin. Y'all want to keep that definitely in the forefront of your mind. Highlight that. Remember that. Make a note. So is vinegar Acidic or alkaline?
I wouldn't say acidic.
All right.
Acidic.
Ammonia.
What would you? Yeah.
Okay. All right, keep reading.
Okay.
Oh, where you was at?
Okay, I'm down to the first bullet where it says the ionization of water is what makes pH possible. Because only
Aqueous.
Okay.
Aqueous.
Yeah.
Aqueous, which is water solutions.
Water solutions have pH. Non-aqueous solutions such as alcohol or oil do not have pH.
Okay, and what does pH mean again?
Potential hydrogen.
What is it?
Potential hydrogen.
Okay, keep going. Next bullet.
In pure water, every water molecule that ionizes products produces one hydrogen ion and one
Hydroxide.
hydroxide ion. You're going to look at figure 7-11.
Mm-hmm.
Pure water contains the same number of hydrogen ions as hydroxide. How can I say it?
Hydroxide, like peroxide.
Oh, hydroxide. I don't know.
Mm-hmm.
One hydroxide ion. Look at figure 7-11.
Mm-hmm.
Pure water contains the same number of hydrogen oxide ions as
Tongue twister.
As hydroxide ions,
Mm-hmm.
which makes it neutral as
denoted.
Denoted by the number 7 on the pH scale.
Because the scale go from what to what? What's the range of the scale?
0.
All right. That's why 7 is the neutral, because it's in the middle.
8.
Mm-hmm.
By number 7 on the pH scale, this means that pure water is 50% acidic and 50% alkaline.
Mm-hmm.
The letters pH denote potential hydrogen,
Mm-hmm.
which is the relative degree of acidity or alkalinity of a substance.
Mm-hmm.
The pH scale measures the concentration of hydrogen ions in acidic and alkaline. Water-based solution. Notice that the pH is written with a small p, which represents quantity, and a capital H, which represents the hydrogen ion.
The amount. Mm-hmm.
The pH scale. The pH values are arranged on a scale ranging from 0 to 14.
Mm-hmm.
A pH below 7 indicates an acidic solution. A pH of 7 is a neutral solution.
Mm-hmm.
And a pH above 7 indicates an alkaline solution. And once again, figure 7-12, you can look at that at the bottom. The pH scale is a logarithmic scale, which means that a change of one logarithmic scale, which means that a change of one whole number represents a tenfold change in pH. For example, a pH of 8 is 10 times more alkaline than a pH of 7.
Mm-hmm.
Didn't know that. A change of two whole numbers indicate a change of tens.
Mm-hmm.
10 or 100-fold change. Come on. Therefore, a pH of 9 is 100 times more alkaline than a pH of 7.
Mm-hmm.
The pH range of hair and skin is 4.5 to, as we had discovered, 5.5, with an average of 5 on the pH scale. This means that pure water is 100 times more alkaline than hair and skin, even though it is a neutral pH. In fact, pure water can cause hair to swell up to 20%.
Alexa, stop. Keep going. Oh, where we at?
We at
Okay, at the end. All right. So let's do your pH scales in your workbook. Do you need y'all need color pencils or anything like that? Crayons. You say you do? Tractor. All right, so we will. What time? Oh, it's 10:15. All right, so yep, work on doing your pH scales, and then tomorrow, well, honestly, I'll check those. Vincent, did you finish your review questions?
I ain't done. I still got like 5 minutes.
Okay. So once you finish this exercise and this worksheet, then complete your review questions. Then they'll be turned in. I only have Octavius and Marcinus so far. Anybody that is tuning in virtually, submit your Chapter 7 review either by dropping it off or emailing it in. What we're going to do tomorrow is, which you can continue reading, but tomorrow we will finish reading from 189. We'll read 189 and try to go ahead on to 200 to knock out the rest of the chapter for those audio learners. That way y'all can catch this on the replay. And then what we'll also do is we'll go over our review questions together. What I want y'all to do with the review questions, when we get ready to go to review, you're going to highlight inside of this chapter those answers. So that way, when you're studying using your textbook or whatever, you still highlighting things that you already done been asked. This just building your awareness and your insight and your knowledge when it comes to theory. Mm-hmm. Next week. Next week, yes, ma'am. It's here. All right. So that is the assignment. We're not going over nothing. Yes, so we are done. We are done when it comes to morning theory. Because they are working on their pH worksheets completed. You can find it on page 188. And that's it. That's all. I am Tiffany, your dynamic instructor. And we are out. Let me let y'all look at our classmates over here working diligently. They working. See, they minded they yes. All right, y'all know theory is first base. Make sure you get your work in. We will see y'all. This is texture week. So when we leave here, we will go on the clinic floor and get into it. We're going to cut up a little bit on the clinic floor. So we'll check y'all out later.